All right, in lesson arithmetic sequences. An arithmetic sequence is a sequence where all the terms differ by a common number. So you're adding or subtracting, so adding a negative, the same number to go from one term to the next and to the next. So the first one, each term is 4 more than the term before. So that's a common difference. So it is arithmetic. In the second one, we're adding -7. So there's a common difference of -7. So it's arithmetic. The general term, this is not a recursive formula, right? It doesn't depend on the prior term. It just depends on A, the first term, which is t sub 1, n minus 1, so n is the term number, times the common difference, which is a lot like slope, to be honest, but it's the common difference here. Okay, so for each of the following, find the general term in the 10th term. So A is -4, D is +4, Tn is equal to A plus n minus 1d. So -4 plus n minus 1 times 4, 4n minus 8. I'll show a step. -4 plus 4n minus 4, we are distributing. So 4n minus 8. We still have to get T10. I wrote too big. So T10 is equal to 4 times 10 minus 8, which is 32. Try the next two, and then check using the solutions online. Determine the numbers, so pause the video, try B and C, and then check to see if you match up. 2A, determine the number of terms in the sequence. So for A, we have the initial term number, A or T sub 1 is that. The difference is that we're going up by 7. So Tn is A n minus 1d. So Tn is -17 plus n minus 1 times 7. So that works out to 7n minus 24 Tn. Now, this is a finite sequence. We want to find out what n is. What is n when the final term is 151? So we plug that in. 151 is equal to 7n minus 24. Add 24 to both sides, so that's 175 is equal to 7n. And n is equal to 25 terms. So there are 25 terms in the sequence. Now for B, they want us to write it as recursion. Well, that's actually pretty simple for this. We're adding 7 each time. So you take yesterday's number, the number before, and adding 7. And of course, the C term is -17. And there's the recursion. So writing arithmetic series sequences as recursives is actually usually pretty easy. Determine if the sequence is arithmetic. Well, I kind of already did. The sequence is arithmetic, and the formula is not given here. So let me just write down the formula. Tn is equal to 6 minus 3n. So just try it out. What is T1? 6 minus 3 times 1 is 3. T2 is 6 minus 3 times 2, which is 0. T3 is 6 minus 3 times 3, which is -3. T4 is 6 minus 3 times 4, which is -6. See how there's a common difference here of -3. This is like first differences, right? It's linear. Common difference. So our determination is based on the fact if there's a common difference of -3. So this is arithmetic. Okay. Oh, there's the formula on the next page in my version here. T8 is negative 49 and T15 is negative 84. They're saying find A and D in Tn. Now, they're implying that's arithmetic, so that we have to assume that if they're asking us for A and D, it has to be arithmetic. And we're going to do it a couple of ways, I guess. When n is 8, T8 is negative 49. So remember, we're going to use Tn is equal to A plus n minus 1d, right? So here we go. Negative 49 is Tn. A we don't know. N minus 1, well, n is 8, n minus 1, so that's 7d. When n is 15, t sub 15 is negative 84. Negative 84 is equal to A, n is 15, 15 minus 1 is 14, 14d. Now we need to solve this. So we're going to use elimination. Number of these is 1 and 2. I'm going to do 1 minus 2 gives us 35 is equal to negative 7d. D is then equal to negative 5. We'll sub that into equation 1. So we get negative 49 is equal to A plus 7 times negative 5. That's negative 35, so we're adding 35 to both sides, 14. So we have D, and that's A equal to A. So we still need Tn, so Tn is equal to negative 14 plus n minus 1 times negative 5. So negative 5n minus 9. And maybe I'll list the other two things we were to find. There it is. Now, I guess that's all good. There is another way you could maybe think of it. So just one more way to think of it. We're going from T8 to T15. So we're adding 7 to the term number to the n, right? And we're going from negative 49, right, all the way to negative 84. This is a change of minus 35. So 7 differences, right, because we're going 7 term numbers, is equal to negative 35. So D is equal to negative 5. And then, because of the way they gave us the information, otherwise it would be a little more work. T1, it's another 7 differences, right? This was 7 differences. This is another 7 differences. So we have to go negative 49 minus 7 times negative 5, right? So we go to negative 14, which is our A value, right? So, you could think of it logically that way too. But a lot of people are more comfortable sort of just setting up the equations using the general equation for an arithmetic sequence. Last example. Justin invests $3,500 in a saving account that earns 2% simple interest per year. How long will he need to leave his money in the account if he wants to have $4,830? So the interest for 1 year is 3,500. I'm doing PRT. 3,500 times 0.02 times 1 year is simply $70 every year. Okay, so the initial amount after 1 year is 3570. That's T1 after 1 year. And Tn that we want is 4830. And of course, D is $70. So, right, we're using Tn is equal to A n minus 1 D, 4830, 3570 plus n minus 1 times 70. Now, when I do 4830 minus 3570, what do I get? I get 1260 is equal to n minus 1 divided by 70. Divide both sides by 70. I get 18 is n minus 1. And n is equal to 19. So at time 0, there's $3,500. And 17 years later, we would have 19 years later. So it will take 19 years to reach 4830. And that's it.